We're starting into a section of the course where we're going to be talking about light and optics, and we're going to start by looking at things that light does that show its wave nature. Now, we've talked about light as a photon, but we've also talked about light as a wave, and for the next couple of classes, it's all light as a wave. And one of the crucial things that light can do when it's behaving like a wave is it can diffract. And diffraction means this: when light goes into an opening, if it diffracts, it spreads out and it comes out the other side. But then you can have some interference, and when the light spreads out, you can have interference between the light that takes different paths, and so you can have constructive and destructive interference. So I want to look at some examples of that today. Now we're going to start with this. I've got a laser which shines through this little device and projects on the screen, and right now there's nothing in the way of the light, and so I just see a bright dot where the laser pointer hits. So it's just a bright dot. But now I'm going to put something in front of the dot, specifically a thin slit. And when light goes through this thin slit, what it's going to do is this. There's going to be a diffraction. The light is going to spread out, and then you're going to have an interference of the light from one side of the slit and the light from the other side of the slit. And I get this interference pattern where I get dark spots and I get light spots. So you can see I get this central light area, and then I have a dark band, and then another light area, and then a dark area, and then a light area. And we're always going to be interested in the size of this central maximum right here, the size of the central bright piece. That's the piece we're going to be concerned with. And it turns out the size of this central maximum, we call it, is related to the size of the slit. If I have a wider slit, I will have a smaller central maximum. And we can see that if I change the size of the slit, I made the slit bigger, I get a much narrower central maximum. Okay? Now, I'm going to dial this back so that this is open again. And I'll show you another thing. One really interesting thing that happens with light is when light goes through a slit, I get this diffraction pattern. But also, if light goes by a small obstruction, say like a piece of hair, I managed to donate a piece of hair, and given how little I have, this was a sacrifice. This is the sort of things I will do for you people. So I hope you appreciate that. Now, I'm going to take this single strand of my hair. Oh, by the way, in the color of the hair, you might think it's white. It's not white. That's a piece we'll talk about next week when we talk about color a little bit. If I take this hair and I put it in front of the beam, there's a diffraction pattern that shows up on the screen. And it's exactly the same as the single slit pattern. It's exactly the same. As a matter of fact, we can use the same mathematics to analyze that pattern as we did for the slit, and it will tell us the width of the hair. It will tell you how thick or how thin my hair is. Not how thick or how thin my hair is because we know it's thin, but how thick or how thin an individual shaft of the hair is. And it's actually a very, very accurate way to measure small objects. Historically, people did that to grade wool. They would take single strands of wool and they would put them in front of a bright light source and look at the diffraction pattern. Very, very interesting. Now, another thing we'll look at is what would happen if instead of having one slit, I had two slits. And if I have a double slit pattern, what I get is I get this pattern where I have a pattern, a range of kind of like light and dark images. Now, they're really, really close together. And I get a very, very tiny spacing of the light and the dark bands. And so I have this double slit pattern right here. The other thing we're going to look at is if I have multiples. And if I take multiple slits, if I have many of them, okay, let's go ahead and pull some of those up. Multiple slits, what it does is it crisps up the positions of the dark and the light patterns. And here's a multiple slit. And you can see I've got a series of very, very bright spots with dark in between them. And so I've got m is equal to 0 here, m is equal to 1 out to the side, m equals 2, m equals 3, m equals 4. I get successive orders of diffraction, and that's from a multiple slit. And the spacing of the slits determines the spacing of the spots that you see on the screen. You can look in the textbook for details of the mathematics, but if I make the spacing here smaller, I will make the spacing here bigger. And if you have lots of slits, I end up having what's known as a diffraction grating. And that's the main thing we'll work with. So if I look at these glasses right here, these glasses have a diffraction grating inside them, a whole bunch of lines very close to each other. And if I take this and put this in front of the laser, what I get is I get very, very widely spaced dots. I get very, very widely spaced orders of diffraction. The Little Shop of Physics gives out these very, very sassy glasses. And when you're next on campus, you can stop by my office and I will give you a pair. It was my intent to give everybody a pair because not only are they sciencey, stylish too. I mean, check it out. Wouldn't you want to sport a pair of these at your next social event? Oh, we don't know when that's going to be, but when it happens, doggone it, you want to be rocking a pair of these things. You know that you do. This has got slits that go vertically, but it's also got slits that go horizontally. As a consequence, it makes this pattern of dots, makes a network of dots that goes vertically and horizontally here. A few more things I want to show you vis-a-vis diffraction. One is, we saw what the diffraction pattern looked like from a single slit or a single line obstruction, a piece of hair. This is a slide with blood cells on it. And when they put the blood cells on here, they're going to look like little discs. They're going to look like little discs, little circles. And if I take my blood slide and I put it in front of this laser beam, what I get is I get a sequence of dark and light circles. And by looking at the size of the central bright circle, I can tell how big the blood cells are. And this is something, too, that people used historically to measure the sizes of really, really tiny objects. I also want to talk about the idea of a reflection grating. Here's a DVD, and you know with a DVD, you get kind of like interesting rainbowy reflections off of it. That's something that you've seen before. And the reason is, there's a pattern of light and dark. There's a pattern of grooves on here where the information is recorded. And if I take this laser and I bounce it off the CD, I can get a pattern of light and dark lines. There's a diffraction pattern that comes off here as well. And that's most clearly seen if you look at the rainbow pattern that you get. So I get a pattern of dark and light that comes off here. I get a diffraction pattern. And if I have different wavelengths of light coming in, if I have white light coming in, I get a very, very interesting rainbow pattern because different colors will reflect at different angles. And so I get this interesting pattern off of here. Now this is something that's really common in nature. There are beetles and one snake and a few other creatures in the world that basically use that reflection grating to produce their colors. And so they're colorless. But when the light hits them at different angles, it produces this diffraction rainbow. And apparently, that's a really sexy way to make color. Other creatures seem to really like it, but it's also really good for protective coloration. It makes them very, very difficult to track visually. So all this stuff here is related to the phenomenon of diffraction and interference. It's an example of light behaving as a wave. Oh, but there is so much more. We have so much more to talk about in this section. So we'll see more in a little bit.